Okay, in 6.2b, we are proving that quadrilaterals are parallelogram, all the ways to prove quadrilaterals are parallelogram, and this is on page 423 in your book. This actual chart is on page 425. Okay, so these are the 5 things you have to know. Actually, in the chart in your book, 1, 2, 3, 4, 5, I think it's all there. So these are all the things you have to know, things you have to use to prove that quadrilaterals are parallelograms. So number 1, if you know that both pairs of opposite sides are parallel, then it's a parallelogram. Number 2, if both pairs of opposite sides are congruent, then the quadrilateral can be proved to be a parallelogram. Number 3, if one pair of opposite sides of a quadrilateral are both parallel and congruent, so you know that one set of sides are both parallel and congruent, then you can prove it's a parallelogram. Number 4, if the diagonals bisect each other, then it is a parallelogram. And number 5, if you can prove that both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So you have to use one of these 5 methods when you're trying to prove a quadrilateral is a parallelogram. So in these exercises, we're asked, is it enough information to prove that a quad is a parallelogram, and what would the reason be? So number 1 is yes, we can prove this is a parallelogram because one pair of opposite sides is both parallel and congruent. I'm not going to write it all in, but one pair is both parallel and congruent. Number 2, yes, we can prove this is a parallelogram because the diagonals bisect each other. Number 3, yes, we can prove this is a parallelogram because both pairs of opposite sides are congruent. And you have to write out the whole thing, exactly what I'm saying. Both pairs of opposite sides are congruent. In number 12, I know this pair is congruent and the other pair is parallel, so no, that's not going to do it for me. You have to have the same set, both parallel and congruent, if you just have one pair of sides. Number 5, since I know this angle is congruent to this angle, that tells me that these 2 lines are parallel. And then since we know the other 2 are also congruent, it tells me these other ones are parallel. So yes, that can be used to prove they're parallel. It's a parallelogram because both pairs of opposite sides are parallel. In number 6, if I don't know all I know is it's a quadrilateral. So I would add up the sides and figure out this last side. Actually, I don't even have to do that because we know that these 2 are add up to be 180, so they're supplementary, so they're same side interior angles adding up to 180. So that tells me that these are parallel. Same thing with the other 2. They add up to 180, so they're same side interior that are supplement, so it tells me these are parallel. So that would be a yes because both pairs of opposite sides are parallel. Okay, on the next page, they're going to be asking this question: what additional information is needed to prove that a quadrilateral is a parallelogram? So in number 7, I need another set of, I could have 2 things. The other thing could either be that AD is parallel to BC, or if we knew that AB is congruent to DC. Either one of those would be enough to prove that number 7 is quadrilateral. Number 8. So I'm starting with AB is congruent to DC. So again, I could have the other sides congruent, AD being congruent to BC. Or I could have these same sides being parallel, AB parallel to DC. Number 9, I have DCA. So I have one set of opposite sides congruent, DCA and BAC. I would need the opposite, one set of opposite angles are congruent, I need the other one. So DAC congruent to BCA. Number 10, DE is congruent to EB. So it's told me that one of my diagonals is bisected. I would need to know about the other one also. AE also needs to be congruent to CE. So both sets of the diagonals bisect each other. Both sets you'd have to know. Number 11, I've got CDA and DAB. So that's one set of consecutive sides are supplementary. I need to know another one. So maybe DAB plus ABC also being supplementary. And then I would have enough. In number 12, what value of x and y will make the polygon a parallelogram? So 3x is going to have to be equal to 6. So x would have to be 2. And then once I know x is 2, I'll set the other equations equal to each other. So 2 plus 2 equals y minus 1, and y is going to equal 5. In number 13, opposite angles must be congruent. So 2x must equal 70, and x must equal 35. 3x plus 5 is going to have to equal x plus 3y. And I'm going to fill in the x. So 3 times 35 plus 5 has got to equal 35 plus 3y. Go ahead and finish solving that. And did you get y equals 25? For number 14, these are giving me the diagonals. They've got to bisect each other. So 3x has to equal 12, and x has to equal 4. And then x plus y has got to equal 5y. So that's 4 plus y has to equal 5y. 4 has to equal 4y, y equals 1. Okay, now we're going to start on proofs. So the first proof is I've got two triangles, and I want to prove that this whole thing is a parallelogram. So what I'm going to do is I'm going to show that I'm going to use, what am I going to do? Okay, I've already got that I have two triangles that are congruent. So triangle MJK congruent to triangle KLM, and that is given. So because those are congruent, I'm going to say this angle is congruent to this one. So number 2, angle JKM is congruent to angle MKL. I'm also going to say this one is congruent to this one. So angle JMK is congruent to angle LKM, and both of those are CPCTC. Number 3. Okay, because those two angles are each of those angles are congruent, I can now say that JK is parallel to ML, and JM is parallel to KL, and that would be, so you got to write this whole thing out. If two lines are cut by a transversal, I'm not going to write it all, but if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So I'm expecting you to write it all out. If two lines are cut by a transversal and alternate interior angles congruent, then the lines are parallel. So I've just said that these are parallel. So I can now say that MJKL is a parallelogram, and the reason would be that both pairs of opposite sides are parallel. Okay, in the next proof. Number 1, I'm given AB is congruent to CD. These should say congruent. BC is congruent to AF, and also angle AFD is congruent to angle ADF. So I believe this is all marked. A, B, and C, D, AF, and BC, and basically angle F and angle D. Number 2, I'm going to say that AF is congruent to AD. So I'm saying these two are congruent, and that is because if two angles of a triangle are congruent, then the sides opposite those angles are congruent. Number 3, I'm going to say that AD is congruent to BC. And that is because that's because I said AB in the beginning. This is going to be transitive. Because it goes back to the BC being congruent to AF, AF also being congruent to AD, so this first one is congruent to this one. AD is congruent to BC. Number 4, I can now say ABCD is a parallelogram because both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. Okay, I'll write as much as I can of this proof, but you're going to have to fill it in better than I do. I can't squeeze it in very well. Maybe I can give myself a little more room. Okay, number 1, triangle RQP is congruent to triangle ONP, and R is the midpoint of MQ. 1 is given. I'm just going to mark those. So we know the triangles are congruent. Triangle RQP, this triangle, to triangle ONP, and R is the midpoint. So, number 2, QR is congruent to, I'm actually saying QR congruent to NO right now. And that would be CPCTC. And you're going to see why I'm doing this. Number 3, QR is also congruent to MR. And that would be definition of midpoint. Please write it out. I'm going to abbreviate because I don't have much room. Number 4, I'm now going to say NO is congruent to MR, and that's transitive. So that was just stated in these two. I can now say transitive, NO and MR. So I have NO and MR. Number 5, angle RQP is congruent to angle ONP. And those go back to those original triangles. So again, it's CPCTC. Angle RQP and ONP. And then number 6, I'm going to say that, let me mark those again. That was Q and N. And now I know that MQ is parallel to NO. MQ and NO. I could also call it MR right here. It's parallel to NO. It's the same line. And that would be, again, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. I'm going to let you write it out. Number 7, I am able to say that MRON is a parallelogram because one set pair of opposite sides, so this is my answer for number 7, one pair of opposite sides are both parallel and congruent. Are both parallel and congruent. So I am getting that from number 4 and number 6. There's my one set that's both parallel and congruent. Okay, in number 18, it wants to know why AD is always going to be parallel to BC. So there is parallelogram in there, and they're giving the sides, and the opposite, both pairs of opposite sides are congruent. So therefore, it has to be a parallelogram, and therefore those two sides are always going to be parallel, which would be good because they want the pole of that basketball hoop to be straight up and the backboard also. And in number 19, the headlights of the car have the shape shown at the right. Explain how you know that B and D are going to be congruent. I have one pair of opposite sides that are both parallel and congruent. So therefore it has to be a parallelogram. And if it has to be parallelogram, then the opposite angles have to be congruent. Okay, in example 20, it says in quadrilateral, I'm going to draw this quadrilateral, G, H, J, K. So I'm going to do G, H, J, K. G is 55, H is 125, and J is 55. So they want to know, to find angle K, what theorem can you use to show that, and then what theorem can you use to show that that it is a parallelogram? So just knowing that it's quadrilateral and to find J, we don't know anything's parallel or anything yet. So we could do it this way, 125 plus 55 plus 55 plus angle K is going to give us 360 since it's a four-sided figure. And from that, we can get angle K coming out to be 125 degrees. So once we know it is 125 degrees, then we have that it is a parallelogram because both pairs of opposite angles are congruent. All right, so number 21, it's telling us for this quadrilateral to be a parallelogram, what is x going to be? So that means this diagonal is bisected. 5x has to equal 2x plus 9. 3x equals 9. X would have to equal 3. For the second one, same thing. These two the diagonals are bisected. So 2x equals 4x minus 7. Go ahead and solve this. Come back to me. I got x equals negative Oh, I got x equals positive 7 over 2, or 3.5. Now, these are the 5 ways to prove quadrilaterals are parallelograms. So this summarizes the 5 things that you need to know. You're going to use one of these to prove quads are parallelograms. So look them over, make sure you know them very well, and then I will start to do these. I'm just going to do 2 proofs here. So this proof, we are proving that regular hexagon JKLMONO, and inside that we're proving that OKLN is parallelogram. So number 1, we are given hexagon JKLMNO, and it's a regular hexagon. Really important that we're given regular hexagon, that hexagon that is given. So because it's a regular hexagon, there's a lot of things I can tell you about it. I can say ON is congruent to KL, and that would be definition of a regular hexagon because all the sides are going to be congruent. So far I've said ON and KL. Number 3, I'm going to say that JK is congruent to ML. I'm also going to say that JO is congruent to MN. Same thing, definition of a regular hexagon. I'm trying to get to the point where I can say that these lines are congruent. Number 4, I'm going to prove, first I'm going to say angle J is congruent to angle M, and that is also the same thing, definition of a regular hexagon, all the angles are congruent. I've now got enough to prove these 2 triangles are congruent. So I'm going to say triangle OJK is congruent to triangle LMN, and I've done that with side angle side. Now I can say OK is congruent to LM, and that is CPCTC. And now I can say that OKLN is a parallelogram, and I've done it with both pairs of opposite sides are congruent. Both pairs, opposite sides, congruent. Okay, this next proof. I'm not going to do this last one here, so just this one. Not so bad. Number 1, VWKJ and SJRU are parallelograms. One is given. So before I go on, would you please stop and look at it and try to do it yourself? See if you can get anything from looking at this picture. Okay, so I'm just going to say that angle W is congruent to angle J because they told me that's a parallelogram, and opposite angles of a parallelogram are congruent. Number 3, I'm going to say that angle J is congruent to angle U, and that's going to be the same as number 2. And number 4, I'm saying that angle W is congruent to angle U from the transitive property. And that's all they wanted me to do, is prove those 2 angles were congruent.